finish looking at exponential graphs. Okay, so a standard exponential graph looks like this. So that's y equals a to the x, let's say. Right? In which this coordinate right here is 0 and 1. And actually, I'm going to change that. I'm going to make it an actual numerical value so we can use some numbers. 2 to the x. So let's use y equals 2 to the x. Okay? So, just for the heck of it, let's just do a table of values for y equals 2 to the x. Okay? Starting with when x is negative 2. So what is 2 to the negative 2 equal? What is it? 1/4. That's right. What's 2 to the negative 1? Sorry, Kelsey. 1/2. 2 to the 0. 1. 2 to the 1? 2. And 2 to the 2 is 4. So I've just graphed that guy here, and here. Right? Okay, so now, the logarithmic graph is the inverse of it. Log x to the base 2. Okay, on your calculator, I mentioned this the other day, I'm going to show it to you now. Okay, if you look at your calculator right now, you have a log button on there. But that log button is for base 10 only. Okay, so how do you graph a logarithmic graph when the base is changed? Well, I'll show you how to do it manually on the calculator, but then I'll show you how to do it with just pen and paper. So I have the log of x over the log of 2. This is what we call the change of base formula, which we'll get to later on in the unit. But to punch it into your calculator, you graph log x divided by log 2. So you take whatever this value is, the log of that value, divided by the log of whatever the base value is. All right. Now, just doing it on pen and paper. The inverse, we switch the x and y values, but we also have to remember this, that it is a reflection over the y equals x line. Right? That's what the inverse function is. So let's take these values and let's switch them. So now I have 1/4 and minus 2, which is down here somewhere. I have 1/2 and negative 1 right here. Right? 0 and 1 right there. 2 and 1 right here. And 4 and 2 right here. So my logarithmic graph is a mirror image of it. So we did this last week, right? Okay, so it's just a mirror image over this line right here, this y equals x line. Okay, and all I do is I switch these values. Now, because we're in the pre-calculus class, all we need to remember are the 4 characteristics of this graph right here. We just need to sketch it. We don't have to have specific points. The only specific points we need when it comes to sketching are your intercept values. Okay, so x and y, if there are, right? And maybe one other coordinate on there. But in this graph here, what is, first of all, I'm going to draw this line down here like this as well, because that's natural. So what is the x-intercept of this graph? Where's it across the x-axis? Is it? At 1. Right? Our x-intercept is 1, right there. Okay, so 1 and 0 would be the coordinate. Fair enough. What is the domain of this graph? X is greater than 0. Awesome. What's the range of this graph? Element of all reals. And what is the asymptote of this graph? Y equals 0? The equation of the vertical line, x is equal to 0. That's your asymptote. Okay, and that doesn't change. So the difference between what you're doing in applied right now, where you're doing the equations of best fit and whatever, you're going to use your basic rules now for logarithm. Y equals log b x minus c plus d. Okay? A again affects all the y values. You multiply by the y values, right? B, multiply all the x values by 1 over b. Divide all the x values by b. C does what? Moves them left or right, and D moves it up or down. Same thing we've done all year so far. Doesn't matter which, same thing we've done all year. Okay? The biggest thing that you need to know right now, that's the start of it. The biggest thing you need to know, you want that up there? Oh. Okay, is how do you go from this and change it into a logarithmic equation? Okay, and then you want to be able to go back again. So what we're doing is we're going to use either exponential equations or logarithmic equations, whatever is going to make it easiest for us to solve the questions. Okay? In the last section we worked with exponential. A lot of that was like they talk about exponential growth and decay, whether it's population, whether it's chemistry in terms of half-lives or masses, okay? When we use logarithms, these are the types of graphs that we use for seismic graphs. Anybody know what a seismic graph is for? Earthquakes. Right. So this is what you use logarithms for. So when they talk about the Richter scale, they measure it on a scale of base 10. Okay. So how strong is a 10? Like an earthquake to the power of 2, like an earthquake that registers 2.0 on a Richter scale. Okay, or earthquake that registers 3 on a Richter scale. What's the difference in the amount of strength? That's what we use logarithms for. Okay, there's 10 times stronger a 3.0 than a 2.0 because you go 10 to the power of 2 to measure the magnitude of it, and then a 10 to the 3 would be 10 times stronger than a 2. So when they talk about it on TV, when they hit a 7.2 on the Richter scale, that's 10 to the 7.2. So it's a pretty massive earthquake. Okay, so how do I go from here to work with logarithm, and then how do I go back? So here's what I do. I put the log here on this same side as the exponent. I go the log of this value to the base of that. I'm going to do that right. Hold on a second here. Make sure I got that right. Yeah, makes sense. No, hold on. I already messed up. My bad. Thinking about this. Okay, so it's a log of this value. So I put it on this side, and then this comes down and becomes my base over here. So it's a log of x to the base a is equal to y. So to put it back, I raise that guy up to here. This becomes the exponent, and it's equal to x. A to the y equals x. So we want to, that's the number one thing that we want to be able to do is convert or switch from exponential to logarithm and logarithm to exponential. All right, and they show you this on page 260. So I'm going to show you how this works. First one, 3 to the 4 is equal to 81. So it says, okay, rewrite this exponential in logarithmic form. So the log goes on the same side as the number that's down. So the log of 81, my base for my exponent, becomes my base for my log, 3. And what is the log of 81 to the base 3 equal to? 4. So that's how we convert it. Okay? You can have a go at this. 36 to the 1/2 equals 6. Change it over. What's the base in this question? 36 is. Yeah, very good. So it's the log of 6, the base 36 is equal to 1/2. Everybody okay with that so far? Okay. I'm going to show you something to make it make more sense. Let's take this guy for example. Now I just finished telling you a little bit ago that these logarithms all have these same laws that exponents do. Okay? They're very similar. All right, and we're going to get into that in a bit. But here's what I want you to see. The log of 81 to the base 3. Well, what is 81 to the base 3? 3 to the power of what? 4. So if I rewrite this guy, 3 to the power of 4 to the base 3. Somehow that has to equal 4, correct? That's what I said right here. Right? Well, here's the rule. Okay, you know how we have an exponent to an exponent rule? In logarithms, when we have an exponent, we take the exponent and we move it in front of the log. Okay, this is the law. We're going to get to this. This will be an 8.2. So next week we'll get to this. So I take that exponent and I move it over in front. So now I'm left with 4 to the log of 3 to the base 3. Okay, that's just a rule. We'll follow it. What do you suppose the log of 3 to the base 3 is equal to? What do you think? Log of 3 to the base 3. What do you think it's equal to? Well, what does the whole thing have to equal? The whole thing has to equal what? 4. So what does the log of 3 to the base 3 have to equal? 1. That's right. Okay? Any number, one of the rules, the other rule, any number, a log of a base, or log of a number to the same base is equal to 1. Right? Okay, so, and I'm just going through this quick. You do not need this yet. We will get to this. But if I had it like that, let's just say I rewrote it. Log of 3 to the base 3 equals x. And I wanted to solve for x. Okay? So I'm going to quickly change it. So this is our goal. I now want to take it from logarithm to exponential. So to do that, I move this up so it becomes my base. I have 3 is equal 3 to the x. Right? What does x have to equal if those two sides are equal? 1. I'm done. Okay, so these two rules right here, we'll get to in 8.2. What you're going to need to have done for Monday will be to the end of 8.1. So you need 7.3 done, you need 8.1 done. Okay, for Monday. All right, now, you are, for most of you, or half of you are in that applied course, so you are still working on the graphs in applied, so you should be able to get through this fairly quickly. All right?